Hello and welcome back to another Oasys Top Tips. Did you know that you can fix nodes in your model in D3PLOT so that animations and spatial contour data values are relative to the fixed frame? Have you ever made a model like this Honda Accord crashing into a wall and wondered what it might look like if the wall crashed into the car instead? Well, the good news is that D3PLOT makes it really easy to fix parts of your model in space and visualize the motions from a whole new perspective. To start with, we need to select the Deformed Tool, which you might be familiar with if you've ever needed to magnify the displacements when inspecting a model. The first feature I'll show you is Fix Node. The Fix Node tool does what it says on the tin and allows you to fix a node in space so that everything moves relative to it. Let me show you this in action. So first I'll select Pick here, and then I'm just going to pick a node on the roof of the car that I don't want to move. So I'll select and then the nearest. And now what we can see is the animation has updated so that the car remains fixed and the ground and the wall move towards it. Voila, we've achieved our first purpose. It's important to note though that fix node just fixes the node in terms of translation, so any rotations around that node will still exist. You can also show the node by toggling here, and we can see that node on the roof. Or we can turn on reference node options, and this is used, say, if we wanted to contour things like displacements or accelerations or velocities, and it will give those relative to the fixed node. So I can just toggle that on, and I'll be presented with this information window if I've not used this before, which is basically telling me if I want to update my user-defined data components. Don't worry if you don't know what user-defined data components are, but if your model does have them and you're using them, then it's important to note that if they rely on things like displacements, velocities, and accelerations, you'll need to recalculate those in order to use the values relative to the fixed node. Otherwise, they'll remain in the global system. In this case, I'm not concerned with those components, so I'll just click Don't Recalculate. And now I can go to the data and then I can plot, say, the displacements in the X direction. So I'll just contour those, give it a second or two to load. And now we can see that the contours are relative to this node that I picked. So the majority of the car is in this sort of turquoise color, which corresponds to approximately the 0 displacement band, whereas the ground is shown in pink here, and that's because it's moving in the positive X direction relative to this fixed node. So I'm just going to turn off the contouring now, go back to shaded, and come back to the deformed pane and the fixed nodes. Now I'm going to show you the shift deform option. So I'll just toggle that, and a window will appear telling me that I can't use both the fixed node and shift deform modes at the same time. And that's okay because the shift deform mode is basically the fixed node mode, but it also constrains the rotations. So you'll see that when we click OK, we'll be prompted to pick 3 nodes now, and this defines a coordinate system which will be fixed throughout the animations and be used as a relative frame. So for this, I'm just going to zoom into the front wheel here, and I'm just going to pick 3 nodes on the wheel. On the hub, one there, and one here. And now we can see, because we've got show nodes visible, I can toggle that on and off, that we have our node 1, 2, and 3 selected, and also this coordinate system has been defined for us, and that's our relative coordinate system. So now I've just pressed A to auto-scale the model, and we can see that coordinate system, and also note that we have a reference node defined, and that's the same node that we used in our fixed node before. So the reference node is actually separate from the shift deform coordinate system. We can make them aligned, but in this case, it's a different node, and that node is used for the reference values in the contours. I'll just quickly show you now though that we can access the reference nodes with the ref node button here, and we can see that we can either use a single node, contour, relative, velocity displacements, or 3 nodes, and that's what we're using with the shift deformed option here. So if I turn that on, don't recalculate, that'd be the same as going into shift deform and turning ref nodes on here. We then also have quick access to toggle on and off the fixed node and shift deform node options, and we can see both of those definitions here. And we can also see on the screen that shift deform and reference node has been written and updated onto the graphical window. So now I'm just going to go back to the shift to form option and show you the animation with this shift to form coordinate system defined. So I press play here. What we'll see is that the wheel will remain more or less fixed, and the vehicle and wall and ground appear to sort of rotate around it. And that's because now not only are we constraining the translations, but we're also constraining the rotations around the coordinate system that we've defined. So I'll just pause that now. And the last thing I want to show you is that you can also use coordinate systems that you've defined in advance or saved previously. You can access these by clicking on the Save Retrieve button here, and then if you wanted to store one or save one, you press this Store button here, or Get can be used, and you can select one that might be defined. So for example, the ZTF file contained a couple of coordinate systems here, so a engine center of gravity and a transmission center of gravity. If I select one of them and then don't recalc, we can see that that's showing on the screen, and we have that shift deformed and reference node coordinate system defined. And now if I animate, we'll see that it's actually the engine that's remaining fixed, so it's updated the coordinate system that we've been using. Great. So I hope you found this a really useful top tip, and I look forward to seeing you in the next one.